The first time I asked people who wants to live to 120, no one raised their hands in the audience because it's obvious that we associate, for very good reason, aging with disease. The question is, can we break that relationship?
Hello, hello, and welcome to Existential Threads. Are you kind of tired like me of hearing of diet and exercise and more diet and more exercise and how important it is, and some sleep and some meditation, and of course, preactive checkups and tracking and devices, and more diet and more exercise, and you find yourself on the wagon and off the wagon and on the wagon and off the wagon. You feel guilty, but of course, self-discipline is not really a thing. So what if I told you that the number one evidence-based factor that impacts our long-term health is something else entirely that we hardly ever hear about because it can't make a profit? Well, join my conversation with Eric Verdin, who is the president of the Buck Institute for Research on Aging, where we touch on this key factor and so much more. Here we go. What made you transition from more traditional medicine to the interest in longevity and aging?
It's an interesting question because I guess I'd never thought about it in these terms. I went to medical school wanting to do research. So I'm sort of one of these unusual people. I did not go to medical school thinking I'm going to be a doctor. Um, Went to medical school wanting to learn human biology, essentially. And right after medical school, I guess I got caught into the game and eventually got some clinical training. So I did 2 years of clinical training in internal medicine and went in the lab at the time to do finally what I wanted to do, but I never came out of the lab. So I never went back to practicing medicine. And so I've done, my pretty much my whole career in biomedical research, always really trying to see how can what I'm learning have an impact on human health. And in some way, I've worked on a whole series of topics. I've worked for many years on HIV and the transcriptional regulation of HIV, the epigenetics of HIV. And through that, eventually ended up working on aging, which is a switch that happened about 20 years ago in my lab. So in some way, aging became an incredibly interesting topic for a number of reasons. Why it became something that I was concerned about for myself, but also um, we had a really sort of unique outlook on what some of the pathways that regulate aging could be doing. And so when I saw this, and this amazingly enough came out of the work on HIV, which is just shows you how all of biology is united, and the same pathways are at work to control HIV transcription as they are to control our aging. So that was sort of the long-winded answer of how did I end up working on aging.
Wow, and it seems like even more than biology, like I get the impression that in longevity, especially, it's such a multidisciplinary area that you can get maybe insights from even from fields that you wouldn't expect.
That's the beauty of biology. We've gone from a model of biology, which was basically, or medicine, which was driven by 16th, 17th century science when the humans were first dissected and people discovered organs. And we still have a system of medicine which is organized across these systems. You go see a heart doctor, you go see a neurologist for your brain, and these doctors are treating each organ as if it were sort of a different entity, an independent entity. Everything is incredibly integrated. And what one thing that really the space of aging research has brought is what we call systems medicine, which I think aging research is really at the forefront, and hopefully will change the way we think about aging and about biology. But this idea that you're treating all of these diseases, we call it whack-a-mole medicine, because imagine someone comes in with a heart attack at 60. You treat the heart attack, and medicine is very good at allowing you to survive an initial heart attack. And you survive, you keep getting a little older, and aging by itself is the biggest risk factor for all of these diseases that we've talked, heart disease, heart attack, stroke, type 2 diabetes, Alzheimer's, Parkinson's, many forms of cancer, osteoporosis, macular degeneration. The list goes on and on. We're surrounded by people in our families or parents or grandparents who are actually suffering from all of those. So you have your initial heart attack that we treat. You're doing well, you survive, you go home, another 2 years pass. Well, the clock keeps ticking, and aging being the biggest risk factor for these diseases, next is you get some form of cancer. And again, medicine is doing a very good job at treating the cancer. It's not really paying attention to how to prevent it. But so we treat the cancer, and then you survive, and the clock keeps ticking. And 5 years later, you develop Alzheimer's disease. And this is the normal course of aging for many people. And what I think the aging field is bringing is a completely different perspective to this. Not that we're going to be eliminating all diseases or make people live forever. It's not going to happen. But this idea that by 65, you should be already ill with one disease. By 70, you should have two, which is, by the way, the case for most people today in the Western world. If you're 70 years old, you carry at least two of these chronic conditions that I told you about.
Yeah.
Can we change that equation? Can we help people live better longer? And I think, yes, the answer is clearly yes, even simply by lifestyle changes. So that's really what we are about. And of course, the future is to change, more dramatically the way we age. And we can do this in animal models, but I'm really excited about what we can do today in humans.
How would you like to see things change in the way we practice medicine?
So I would love for us to take a much more proactive way we treat medicine. Medicine right now is mostly reactive, and I know some colleagues will. I'm a physician, so I'm not here to bash medicine. So I was trained, and medicine has done amazing things to bring us to where we are today. Our lifespans are double what it was about 150 years ago. So it's an incredibly remarkable achievement. But I think we've sort of reached the limit of this model in a way that the first time I asked people who wants to live to 120, no one raised their hands in the audience, because it's obvious that we associate, for very good reason, aging with disease. The question is, can we break that relationship? And the answer is yes. So by taking a much more proactive way, in a way we look at our aging as young as possible, but it's never too late. It's the other, as young as possible, that's the best, but it's never too late to change this. You can really alter this equation that we make in our mind, which is actually real, between aging and being sick. And I've made the point that I think today most people could live to 95 in good health. Most people. There are always going to be, of course, some people who have an unexpected disease and so on. But for the average population to live to 95 in good health is not a pipe dream. It's reality that we could implement today. And instead, we see a shortening of lifespan, at least in the US, and I think probably in the rest of the Western world.
So regardless of the, emerging science that maybe we're going to see new therapies in the near future, you say that we already have the means to help people live longer, healthier with the knowledge and tools we have today.
Exactly, totally. And the whole idea is to start early. Aging, we treat disease as if the day they happened, there were occurrence, something that happened recently. But we know that the seeds for many of these diseases were planted 15, 20 years earlier. And we know that, disease processes are very long, and there are initial. Right now, we're treating the disease when it's diagnosed. I'll give you an example. Your type 2 diabetes, your blood sugar is above a certain level. If it's 1 unit below, you're normal. If you're one unit above, you're diabetic or pre-diabetic. Well, we know that these numbers change over a long period of time. We also know that once you get to that level of having type 2 diabetes, the process is so ingrained. You have you have the initial lesion, then you have responses from your body, then you have further progression. So it's a long, completely. So you're trying to treat a system that's completely dysregulated, versus starting very early when you have a single modification that you can actually intervene and modify. So that's the vision. Can we really change the way we look at health as a continuum? Can we identify these early signature of abnormalities? And can we treat those? Quite often we treat disease in a way that is very complicated, very aggressive. When the modifications or the abnormalities are very early, they're much easier to correct.
Right.
So that's really the whole vision, switching to a more preventative medicine and understanding that aging and its pathway is the biggest driver of all of the disease that I mentioned to before. People, probably know about statins. So these are drugs that $20 billion a year are being sold of these statins to lower cholesterol. Your cholesterol level is a risk factor for heart attack, is 7 times less important than your age. And so why are we treating cholesterol, but we're not treating age, basically? And so what the science of aging has told us now is that we've identified some of the key pathways that drive aging. So why not target those if they're going to be 7 times more important? That's really, in some way, the whole vision of what we're trying to accomplish.
So just to make it clear, so right now we have some knowledge, some tools, but longevity science is also about finding new therapies and technologies to allow us to make more of an impact on those aging pathways that cause disease. And
yes.
It seems like, I heard you say that you feel that we're now in an inflection point and that now is the time to kind of transition from lab animal studies to humans. Why do you feel now is the time?
It's pretty much it's a historical sort of observation that's been made in many systems. You make an initial observation that aging, for example, can be modulated by genes and drugs. This happened 20, 25 years ago in the models. And it takes a long time. First, nobody believes these data. That was what happened in 1995, Cynthia Kenyon, Lenny Guarente, Gary Rifkin, a whole group of Tom Johnson, a whole group of scientists published these papers, and everybody said, yeah, it's interesting. You can find genes that regulate aging, but it's the exception. Well, it turns out it's not the exception. We have now, just in the little worm C. elegans, close to 700 genes that actually regulate aging. So, and we have drugs. We've identified dozens of drugs. So I think, and a lot of work has been done to validate these pathways. We know what the major pathways are that regulate aging. We don't have a full understanding of aging, don't get me wrong. There's still a lot of work that needs to be done. And so my passion really is between those two poles. I think continue to do the groundbreaking research that we do at the Buck and other organizations to really push our understanding of aging much deeper. And again, as I said, there's a lot that still needs to be learned, but also really realizing the potential of all these discoveries for humans. And I think that I'm equally passionate by both. And that's what we're trying to do at the Buck, really build a whole clinical infrastructure that can, it's hard. I mean, this is one thing that is a bit sometimes disconcerting for me as a physician scientist, is to talk to colleagues who are pure basic scientists who tell me, yeah, we're going to give this to humans. Well, it's really hard. It's hard, it's expensive, it's long. We have to be careful. The last thing that this field can afford is to actually kill some 20-year-old with some, risky intervention that will hurt us, very profoundly. So I think we have to proceed in a way that's optimistic, but we have to do it. We cannot just keep delaying and say, well, we'll do it when it's perfect. It's not perfect, but we have some really strong hints of things that we could do to really change the way people are aging. And I think what's most exciting for me is the public is really responding. There's so much interest. I mean, you're here for a reason. You probably have friends who are talking about biohacking and all of this. There's so much discussion about what's happening in the field. And frankly, Um, Sometimes we have the feeling in the research field that we are being overwhelmed by the demand, how much people are jumping on all kinds of unproven. I joined some biohacking website just to watch, and it's fascinating for me, the interest, but it's also somewhat scary, to be honest, because some people are just going crazy, and I do not measure the risk of what they're potentially taking.
Yes, it's interesting you mentioned this because I actually feel very isolated with my interest in longevity and especially in the science because I do have friends around me who, of course, buy, read all of this book, look, like listen to podcasts about, how to eat better and how to exercise better. And I gotta say that, of course, I understand how important it is, especially as long as we don't have better tools to maybe make those efforts obsolete. But what always concerns me a little bit is that it's as if this is how the public knows longevity as just like tweaking and improving and optimizing your diet and your exercise and your lifestyle. And I feel like it might be misleading that people are not aware that the promise of the science is so much more than that. It's like it could actually become like the next generation of medicine, I assume, where we can help people so much more because I think from what I understand, no matter how perfectly we eat and exercise, we can't like completely avoid the suffering that comes with biological aging at this point. So what do you think about that? Because I see a lot of longevity experts, especially like very high profile longevity experts who publish books and like at the end of the day, most of the public conversation around their work is really those kinds of lifestyle things. And I wonder if it helps the field or maybe it's also a problem.
I think it's a reflection of it's a good observation. It's a reflection of where we are. So the problem is, we is the difference between an association and a causation. So there is clear association with a healthy lifestyle and a long life, free of disease. And there's also evidence that about 93% of your longevity is determined by lifestyle factors, only about 7% by genetics. So you can't, we're not going to change genomes for a long time, my prediction, to modify aging. Although there might be, we're already changing not the genome, but we're using gene therapy for vaccines and so on. So I think I could certainly see a day that this would come for aging as well. But let me see, how do I put this? The problem is that all of the information that we have is based on association. We know that if you exercise, you're going to live longer. But we aggregate exercise, by studying thousands of people and looking, who's exercising or not. What we don't know, for example, is what form of exercise, how much, uh, what's best for you, not for your neighbor. And so there's a real need, and the same goes for everything. Nutrition. We know people who eat vegetables live longer than people who don't eat vegetables. We know people who do sauna in Finland. The more they do it, the less they have Alzheimer's, cancer, type 2 diabetes, and so on. So all these studies exist, but they're not causative. They're not proof. They're just association. We also know, for example, that if you floss your teeth, you live on average 3 years longer than someone who doesn't floss their teeth. I don't think anybody really thinks that flossing the teeth is making you live longer. It's just a reflection of a lifestyle. And so we are at this stage where we have a whole series of observations that tells us that the people who live longer tend to be looking like this. They floss their teeth, they watch what they eat, they exercise, they go to sleep, they sleep well, they don't drink too much alcohol, blah, 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 blah. What's really missing is what are the biggest variables out of all of those? Can we actually identify them for each person? How will you, and this is the whole idea of biomarkers. Can we measure you at age 30 and determine what are your risk factors and introduce some sort of measured interventions? Right now, we have what I call the crazy jungle. I have 30-year-old people coming and seeing me and saying, I want to be on metformin. I said, why do you want to go on metformin? Well, it's an anti-aging drug. I said, well, not so far. Do you realize that metformin is going to suppress your testosterone? Oh no, I never thought about this. Okay, you're 30 years old, you don't want to do this, period, unless you are at very high risk of getting type 2 diabetes. So right now people are hearing things happening in research, and they're not able for first the infrastructure for delivering this type of medicine is just being built with all of these longevity clinics. And even within the longevity clinics, I work with many of them. uh, we're learning. We don't know how to deliver longevity medicine. So there's a whole process, I think, that's going to happen in the next, I predict, 10 to 20 years of really understand how do we actually really do true preventative medicine that's based on biology. Um, that's where we are in the field. So, a lot of people take the situation in their own hand, and they'll take this supplement and that supplement. And I always I do take supplements too. I take people, I tell people it's a bit of a gamble. You're taking a chance based on the animal research, but there's no proof that it will do anything, and it might actually hurt you. So always trying to find that balance of where, what you described earlier in your question is a reflection of where the field is. We're taking baby steps in the direction of a true preventative medicine.
So that person who wanted to take metformin, and like this is what I'm confused about, because it seems like it's almost like a field that is split into two disciplines. There is, like, yes, the prevention, but then there is the research in the hopes to find a better medicine. So if that person is so focused on what they can do individually to optimize their health, wouldn't we want them to be motivated to support the science by maybe, putting pressure on their representatives and maybe getting involved and maybe supporting financially or using their talent to work in the field? And that's what I wonder about, because I know that in the longevity community, there is a lot of talk about how there's a lack of funding still, very much. Like, a lack of funding is one of the major bottlenecks, maybe the one. But if the people it speaks to think that all, like, the best thing they can do is to take care of their individual health in those small ways that we don't even fully know work yet, again, aren't we missing the bigger potential of what the public can do to make longevity science more relevant, more funded, and accelerated?
Absolutely. All of this is actually happening. So, as a burgeoning field, lobbying organizations are being built, clinics are being built, and so we're seeing, a lot of these efforts are happening. We're organizing ourselves as scientists. We just formed a biomarker consortium that brings some of the best people in the field working on biomarkers. So it is. But everybody's impatient. Everybody wants something now, and I think I've argued that we are at the beginning of something that's going to be enormous. I'm convinced about this, uh, based on what we've seen in our basic animals, and I think there's of course need for more funding. There's need for more support. There's need for more interest. I see this, frankly, in the amount of podcasts and uh, uh, documentaries, all of this press that is being generated in the field. That's really good news, because along with this will come uh, education. And along with the education will come a realization there's a potential there that our elected officials could help us realize by giving more funding. So we see a lot of signs that are all going in the right direction. Um, what's sometimes frustrating is to realize that there's already a lot of knowledge that could change human health today, and the feeling that many, I used to say that we had to change medicine. I don't think this is necessary. We don't need to change medicine. Medicine is very good at what it's doing, which is to treat you when you're sick. I think we need to invent a new form of medicine, which is really focused on preventing you from being sick in the first place. And I went to medical school in 1982, graduated in 1982, and we did not have a single class, a word over 7 years of medical school. This was a 7-year program. We did not hear a word about sleep, nutrition, physical activity, or stress. None of those. And so I thought, well, this is horrible. We're missing all of the important things that actually contribute to health. And I talked to friends who graduated or colleagues that graduated 5 or 10 years ago. They told me, yeah, I had two classes about nutrition. Um, and so, we've given up as physicians. And I really believe our mission, the mission of a physician in life is to keep people healthy more than to treat them. So we've given up uh, our authority and our ability to influence people's health by really not paying attention. And I think I'm determined that now that we have these incredible tools to really try to change that equation. And I found an incredible community of like-minded physicians who are all interested in doing the same thing.
That's great. I definitely know that I struggle to find medical doctors who I really feel they see the full picture and that they care. If I tell them that something deteriorates, they don't necessarily have to wait until it's a catastrophe to look at it more deeply. You mentioned that there already have been breakthroughs with animal studies and that you see that amazing things are going to happen. Can you share some, like maybe an example of such a breakthrough that seems promising to you?
Well, there are so many, frankly. At this point, I'll give you the example of calorie restriction, which is a really good story because it started actually 100 years ago, and we would all hope that the translation of basic research to humans would go faster than this, but it's a reflection of how sometimes radically new ideas take a long time to percolate. So calorie restriction is the idea. If you take an animal, a mouse living in a lab setting, and you allowed it to eat as much as it wants, it will eat a certain amount, 3 or 4 grams per food per day. You can then do what we call calorie restriction, is you cut down the amount of calories that you give to this mouse by 20% or 30% or 40% without malnutrition. So you make sure there's enough vitamins and all of this. And what's been shown is that the more you calorie restrict them up to a certain point, of course, you don't want to starve them, but they live longer, up to 30 to 40%. It remains to this day, even though it's 70 to 100 years old observation, it remains the best intervention that we have against aging. We haven't been able to do anything better than this. And so the question is, how does this work? And this has led in some way to a whole field that we call calorie restriction mimetics. Obviously, calorie restriction is very hard to do, and in humans especially. Someone said that it might not make you live forever, but it will certainly feel that way if you which I think, and so that's one way to go. But the other way is what we call these calorie restriction mimetics. These are drugs that you are taking that trigger the same type of response, because there's been a lot of effort trying to understand what happens to the physiology of your body when you are calorie restricting. And what my lab has been studying over the last 20 years is epigenetic mechanisms that are sensing the environment and transducing a response and changing gene expression and really actually delaying aging. And so I'm fascinated by understanding what is it about nutrition or fasting, which is another form of nutrition, that really is able to activate or regulate or modulate all of these aging pathways. So, out of this came a whole series of discoveries of drugs that are acting as calorie restriction mimetics. And I'll give you two examples that I'm sure you've heard about, metformin and rapamycin. So these are two drugs that trigger some of the same molecules that are activated during fasting. And lo and behold, you can take them while you're eating, and your body still has the feeling that you are fasting. And so, big potential there for us to actually apply these drugs to humans and to do clinical trials and try to see, can we really make people live longer? Can we uncouple this link between disease and aging? And so, yes, if I had to really say something that's going to be, for me, exciting in the next 5 years, is the ability to take these existing drugs, they're in the clinic, so you can actually give them to people, and to test to see how does it change the way people are aging.
So for long-living animals like us, it sounds to me that even like mimicking fasting or calorie restriction is even better, because then you don't risk like losing bone mass and muscle mass and
Yeah,
things
you made a statement that I think is very important. Long living animals like us, because everybody focuses on the naked mole rat and and these other models that are supposedly living longer. We live very long. We almost live longer than almost every animal, and based on our size, we should live much shorter. Which means that this is one reason why I think humans are already, as a species, already optimized to live quite long.
like.
And so that the question is that I get asked all the time is, how long can we live? Some of my colleagues are around telling I'm going to live to 150. Some others up the ante. I'm going to live to 180. Well, there's no evidence for this whatsoever, zero. And so when you are hearing these types of statements, I tell people, try to understand, what is that person trying to sell you? And and most of the time they're selling you hope, so not data. So I'm more of sort of a person that's really focused on what can we do now, and I think we can do amazing things. If the whole population in the U.S. would live to 95 in good health, this would be more transformational than anything we can imagine that has ever happened.
Also financially, socially, will
At
be,
every level,
yeah,
every level.
yeah.
And remember that right now in the U.S. lifespan is actually decreasing, and
Really?
we are, yes, it's gone down from 77 to 75, and we are lagging most of the Western world by 3 to 5 years,
Wow.
which is
Okay.
the question is why. Can it be reverted? And so this is sort of global population effect. And we also see something else, which is which is of concern to me in the aging field, is we see a splitting of the population. The wealthy, the affluent, the
Mm,
educated live longer and longer,
right,
and the people who do not have the benefit of all of this living shorter and shorter.
right.
So
And
I,
it's it's interesting. I live in Spain now, and it's I think it's one of the longest living countries. And they smoke and they eat a lot of fried food, and it's like it's just and they also eat all day long. It's like from 8 in the morning until 11 at night. And somehow, it's interesting how it, because in the US it seems like people are more health conscious. Like maybe it's not, it depends where, but it definitely it seems like there are other factors as well. I think you mentioned it also often in your talks about for example, like meaningful connections, community, things that help us.
that's the number one.
Yeah.
That's the number one factor. Paradoxically enough, loneliness is an incredible risk factor for early death, and human
Mm,
connection is the biggest predictor of your long lifespan today. Now, what
wow.
I tell people, because you might say, I thought that the aging field was preoccupying itself with new biology and new drugs, and it's true. The point that I'm making is not that I don't believe these drugs or interventions are going to be available in the next few years. It's just that it's going to take us 5 to 10 to 20 years to get there. And today, there is an incredibly powerful set of interventions that you can already do that will allow you to benefit from those in the future. That's really, how I look at all this. Do everything you can today so that when we come up with these things, you will be ready and available and in the best shape possible.
I completely relate to that. But and you mentioned supplements that you take. Would you like to share what those are? What you believe may be helpful, or is it an individual thing?
Yes, I think so. I usually do not share the supplements that I personally take because, in some way, the way I do it is, I think, the way you should do it. You should do it with the support of a physician. and you should measure in your blood. So there are, today a number of physicians and clinics that will help you to navigate this whole process. So first, there are individual variability. I was vitamin D deficient and vitamin B12 deficient. If your numbers are correct, there's no reason you should take a vitamin D or vitamin B12. So these are two that I would say most people should really look at with their physician. I can tell you also there's some other supplements that I think everyone pretty much could take. Omega fatty acids clearly have been shown to be protective against heart disease. Most of us in the Western world, unless you are in Japan, are deficient or not eating enough fish, enough fatty acid, omega fatty acid. So that's an easy way to supplement. But also, again, there are ways in which you can measure in your blood whether you have a good level of omega fatty acid. If you're a heavy exerciser, creatine is something that many people who do sports will take. And then there's a whole slew of interventions that are coming up from the field. Ketone body esters that I work on, I take them because I invented them. So I'm biased and in terms of what I think they're doing to myself, but spermidine, urolithin A. Let me see what the list. The list goes on and on. There are so many of those that are available. What I think I really wish people would understand is that none of those are proven, and so you are always gambling in some way, and some are more dangerous than others. Obviously, going on rapamycin is a more significant decision if you're 30-year-old than taking spermidine, for example. So, and this is why I think, even though I'm enthusiastic about the biohacking movement, I'm also concerned about it. The biohacking movement for me is sort of a self-empowered way that people are really taking their health into their hands and they want to be taking a very proactive role. So I'm excited about the whole philosophy of it. Sometimes when I'm visiting these sites and looking at what people are doing, frankly, I get scared. I'm thinking, some of these people are crazy. They're doing this that are really potentially dangerous. And sometimes, the thing about biology, you can do something for 10 years and feel good. And 10 years down the line, you'll find you get a cancer that you would not have gotten. So as we think about aging, it's a long process in humans. I would encourage everyone to sort of, just try to focus on the tried and true method, which is clinical trials demonstrating safety, and really, doing this around it, not just completely self-exploration. I think there's clear risk to this.
Right. And maybe I think a lot of people maybe would love to find a practitioner who can help them navigate this, but nobody knows who to trust and whether there is some kind of a database or something where people can find someone in their area. Do you know of such a thing or such an initiative to put together a community of doctors who are willing to do this kind of work?
Well, we are talking internally. We organized actually at the Buck Institute a meeting bringing all of these longevity clinic. It's something I did with my colleague Joanna Benz, who has a longevity clinic in Switzerland and in Poland. And so we held the first meeting last year, and we're going to have the second one this coming December. So this is meeting for professional physicians who are in the longevity space, but we're doing exactly what you described. How do people navigate this? There's anti-aging medicine, which is a term that we don't like because it has generally been sort of doing things that are unproven and somewhat risky, like stem cell injections and so on. It's also linked very strongly to cosmetic medicine, which is not what this is. So, how do we define a whole new field of medicine for it to be taken seriously, for it to be reimbursed? These are all the questions that we're dealing with. And I would tell people, just do your homework, explore, we will come with some better way of recommending, having a society, for example, that would sort of some form of accreditation, or including, that we recognize a clinic as conducting sort of state of the art, what's called as longevity medicine. But we're not there yet.
I wonder what you feel about, you probably, I don't know if you went to Zuzalu, Vitalia. Now there's the initiative of Vitalism, with kind of a vision, for my understanding, to create almost like cities that are with a community of like-minded people when it comes to health and lifestyle. What do you think about that kind of movement?
Uh, it scares me
Really?
because I know exactly what happens at some of those. I think the intent is right. Uh, I know some physicians have gone to this, but there's a lot of what I was describing earlier, sort of a promise, unrealized promise, no, not understanding the risk. I I love the movement. And I really cannot speak to all of the details, but I know some people, some of my colleagues who have been to this told me there was no distinction between, what was real and what was crazy,
Mm,
basically.
right.
So I don't want to sort of diminish the merit or uh, the interest of this movement, because I think it's part of what we're trying to do. But I think again, I would just ask people to be extreme, somewhat conservative in terms of what they're accepting to go in their own bodies, basically, and to understand the risk. That's really the risks are real. If you have physician friends,
Mm.
I cannot tell you how many people, how many stories I've heard, and along with the fact that all of the impurities that exist in many of the supplements that are on sale today, everybody likes to bash on the FDA and the regulatory process and how hard it is. Should it be changed? I think yes. I think it's too slow, too cumbersome, too expensive, and not reflective of what we can do today in terms of targeting drug development. But it's safe. And when one person dies from a drug that's being sold by big pharma, everybody goes up in arms. Oh my God, how could that be? Big pharma is profiteering. But I hate to think of how many people are potentially getting hurt from supplements that are unregulated and sold on Amazon, for example. That's really where I think there's significant danger.
And my understanding is that in general, even supplements that are of quality, we don't really have clinical trials usually, right? Or not the like gold standard of like they just it's not really the same level of science that we have in drugs,
But it's actually most supplements is zero science.
right?
That's really that simple. It's only something that's been shown in mice, but not in humans.
And in that sense, when you take vitamin B or vitamin D, I know the numbers go up, but how can we know that it actually does something?
Well, again, really good example of where I think there's a problem. So, everyone thinks that vitamin D levels, when they're low, should be corrected. The There have been many clinical trials about what happens when you reintroduce vitamin D and bring the levels back up, and the evidence there is very complicated. I would
Mm.
say a significant number of these trials show absolutely no effect.
Oh, wow.
And but at the same time, there's been some physicians have taken these data to say, well, it doesn't matter, should not correct low vitamin D. But on the other hand, there are some significant problems with some of these clinical trials themselves, which just shows you how difficult it is to prove. Maybe vitamin D is just a reflection of some other process that we're not correcting. And
Right.
so you re-add and this is how the aging field has been working for 20 years. We find level of something is low, we give more of it, and then we think, oh, this is going to solve everything. Well, that low level of vitamin D, vitamin B12, DHEA, the list goes on and on. Maybe it's just a symptom of some other modification that we're not targeting. So uh,
Wow, that's so complicated.
it
I
is that's the answer.
Yeah, it makes me wonder because I know you say like your goal is more toward health span, while maybe some of your peers talk about living to 200 and immortality. And I know you don't. First of all, I would love to know why you choose to speak more modestly about what we can do.
Well, the first one is one of intellectual honesty for me.
Mm.
Um, I could go around and tell you that you're going to live to 200, and I could actually firmly believe it. The bottom line is there's absolutely no evidence for it. So if any of these people talking about living to 150 or 180 can show me what is the evidence that this is going to happen, I will change my tune. I haven't heard it. The second aspect is that almost always when this kind of conversation is being had, there's a commercial interest behind it. I'm
Mm.
trying to sell you something. Of course, if Dr. Verdin comes and tells you you're going to live to 95 in good health, it looks a lot less exciting than to live to 180. And here's my pill. Here are my vitamins. I
Mm.
just want people not to be naive about, uh, we call it snake oil salesman for a very good reason. Snake oil. This is as long as humanity, uh, and and I don't want to be part of that tradition.
Right.
This is what we do is much more important. It is going to be validated. It's going to be demonstrated so people can actually expect some results with what we're proposing.
And as you say, like at some point, it could be that we get to the point where there are new therapies that may allow us to even extend our current maximal lifespan, which is maybe 115 years. So
Yes.
it's not that it's impossible technically it's like right now we're not programmed to live that long, but theoretically it could happen if we find some technology to make it happen.
So that yes, I think you've hit it on the nail because some people have told me, well, you're too realistic. You're a killjoy. You're not allowing people to dream. This is not true. It's totally not true at all. I dream all the time. I dream in the lab where we can do amazing things and we keep pushing the envelope and we have scientists at the back who are, working on all of these models and including my lab and always trying to get to the next level. What I what I no is not available is this for humans today. And there's no evidence. I mean, we've had billions of people living until today. And maximum lifespan, clearly, when you look at the data, very few people, very, very few out of billions make it above 115. And you would expect that out of these billions of people, we would have had some who had optimized genomes and probably there are the ones who already had a very optimized genome. So I, short of everything that we know today, it's going to be very hard to go above 115, 120. But and so and we will get there, but I cannot predict it, and I certainly not going to go around and tell you it's going to happen because I have no evidence for it.
Yes. And I think that people also often don't fully understand the difference between median lifespan and maximal lifespan. And that humans, as far as I know, like it's that the fact that we doubled our lifespan, it's because we've been able to reach our maximal lifespan that we had even when we lived half the time long, right?
It was the same, yes.
Yes. So we haven't changed that. So that's kind of a constant until we find something completely different to break that barrier.
You're totally right. We so slowly we have that genetic endowment, which is how long we can live, and we know it's 115 for most potentially for many humans. We just keep pushing within that envelope, and beyond this, it's going to take something radically different, genetic engineering, whatever, things that we're starting to feel to see glimpses of, but we're certainly not able to do.
We haven't talked about the Buck Institute yet, which is the first biomedical research institute on aging. And you're the president. Can you share some information about the vision of the institute and what you focus your work on?
Yes, so we were the first one to be founded in and actually 25 years ago. We're just about to celebrate our 25th anniversary. And this was at a time when 1995, between 1990 and 1995, there were a whole series of papers that really redefined aging as a process that you could study using the tools of molecular biology, make mutations, use genetic engineering, and so on. So that really changed the way we thought about aging. And the Institute was founded at that time, frankly, by a group of incredible people who had incredible vision of what this could mean. So we're located in the in the hills north of San Francisco, about 30 minutes north in Marin County, which is one of the longest living county in the country. And today we have about 300 employees, all focused on the biology of aging, about 24 faculty members who are directing each their groups. And historically, we're known for, defining much of the biology about what we know about aging. Not all of it, of course. There are many other scientists across the world studying the same thing, but we certainly are the largest in terms of concentration of talent and people who are studying aging. We take sort of we don't have a unique focus, although we've worked a lot on senescence under the leadership of Judy Campisi, our colleague, who was really instrumental in defining the field and who sadly passed away this year. But we have novel initiatives. We just recruited Lee Hood, who is one of the fathers of the whole concept of P4 medicine, the idea that medicine is going to transform to a model which is predictive, preventative, personalized. And we are, along with Lee and his colleagues, trying to build really this new medicine of the future. The Institute itself was really focused mostly on the basic biology of aging. But when I came in about 7 years ago, the vision that I sold to our board was that it's time now to really bring this to medicine and to patients. And so what we've been doing is building on top of the basic infrastructure, basic science, a whole clinical infrastructure that will allow us to do clinical trials. We have 5 clinical trials ongoing right now using different interventions. And we're going to do a lot more in the future. But also recruiting someone like Lee Hood, who's coming and helping us define what this new medicine of the future will be, the whole idea of phenomic health. So these are incredibly exciting times where I think hopefully at the BUC we'll be able to mix the strongest basic science and the best clinical research and really change what we've been talking about all day today.
This is really exciting. I would love to link to those trials. I will contact Lauren to get the links if it's
Yes.
open. And can you, for people who hear this and it might spark their interest in maybe getting involved and maybe working in aging, what do you say to them? Why should we consider going that path?
First, one more thing about the BUC. We have also not only doing the research, but we have a big education mission. And I invite you, if you've never visited our website, it's called bucinstitute.org, and you will find seminars, podcasts, all kinds of information that might interest you about the aging space. And so I invite you to visit, just sign up for our newsletter. I think I can send you the link as well. Now, if you're a young scientist or a young person and looking for something exciting to do with your life, I could not think of a more exciting field than the one that we work on. It really, many people who work in biomedical research work on one disease, and they will start their talk by saying, well, there are 10 million people who are affected by this. Well, when you study aging, there are 8 billion people who are afflicted by this. And this has the true potential to be transformative for all of humanity. So I would say we need a lot more young people, especially in bioinformatics. Computer science is really coming huge into all of biology. And we need the brightest and the best to come and help us to solve that riddle and work on this. It's truly an exciting field to be in.
So I think that's something maybe that people don't know, even that even if you haven't studied biology, there are a lot of other fields that are definitely desired.
Absolutely.
Do you have anything else you would like to share?
Just a message of hope, because some people have told me, well, you're being too realistic. I said, no, I want to change the world, but I want to change it today, not in 50 years. And
Hmm.
I can, of course, there's room for dreaming. There's room for having incredible, audacious dreams. And I think I share them with everyone in the aging field. I also feel that we have a unique opportunity to change the way people are aging today. And so right now we're focusing on this. This is half of our effort. The other half is the dreaming, is really pushing forward and really reinventing aging as we know it.